Yes, good morning. Welcome to the next session of Rehabilitation and Retrofitting of Structures course. In the last session, we have been learned the various causes for deterioration of concrete structure. That is, in the module number 1, we have been learned the various causes or phenomena that are causing the damages in the concrete structure. That is, it may be shrinkage, honeycombing, crazing, a creep effect, that freezing and thawing effect. Like that in module number 3 also the effect of temperature, effect due to wear and erosion. So now we came to know the various causes. That means why it has been or how it will be caused. And also we have been learned the phenomenon of corrosion. How this corrosion that is going to happen. The mechanism. Next, also we have been learned how to protect this corrosion. So in module number 1 and module number 3, we have been learned the various causes for deterioration of concrete structure. Now in the module number 2, that is from the today's session, we are going to learn the assessment, that is damage assessment. So let us proceed with this today. Let us proceed. That is damage assessment. Because we came to know the causes. Now, what the doctor does, he need to use certain things, to do the assessment. That means, now I am going to use certain techniques to assess the damages. For example, shrinkage, honeycombing, we know. Now how to diagnose or how to assess those causes. That I am going to discuss in this particular module number 2. So in the module number 2, we are going to learn the purpose of damage assessment, rapid assessment, and we are going to do the investigation of damage. Next, various investigation or damage assessment techniques. Apart from these things, we are also going to learn about the cracks. What is cracks? Different types of cracks. So these are all the things you are going to learn in the module number 2. Is it clear? So with this outline of a module number 2, let us get into this particular module number 2. So let me start with the first one, that is the purpose of damage assessment. So now my question is, why we need to go ahead with the damage assessment, or what is the purpose of damage assessment, or what are the objectives of damage assessment? See, the very important thing or prerequisite for damage assessment for a building, or when you want to evaluate or when you want to assess the reinforced concrete building, we must thoroughly know about the structural components, that is reinforced structural component behavior. That is, how exactly the beam will behave, how exactly the structural component column will behave, how exactly the structural component slab will behave, how exactly the structural component footing will behave. So, these are all the prerequisites I need to know initially before assessing the damage in the reinforced concrete structures. Because as a structural engineer or as a design engineer, these are all the prerequisites I should know before going to the assessment. Without knowing the behavior of a building, one cannot assess. One cannot come to the conclusion. That this is the so and so damage that has been happened in the reinforced concrete structure or reinforced concrete structural element. Is it clear? For example, I will start with this. Okay, for example, in the beam. You know the beam is a horizontal structural member. It will be subjected to the transverse loading. That means whatever the loading that I am going to subject to a beam, okay, that beam through the longitudinal axis, okay, in the perpendicular direction, all your point load or UDL or it may be UVL, okay, all these loads that are going to be act on the beam, okay, that you already know. And apart from this, okay, this reinforced concrete structural element, you already know it is a composite material. A composite material. That means I need to know the behavior of concrete. I need to know behavior of steel. Because you people know that a concrete is a strong in compression and weak in tension. And you know the steel is strong in tension and somewhat it will take a compression load. So with these, okay, the basics, okay, they are going to combine these two materials in order to form a composite element. That is what reinforced concrete structure. Reinforced concrete structure. Okay, so in order to improve the tensile capacity of a concrete, in order to improve the flexural capacity, so in order to harness all these things, we are going with the composite material, that is reinforced concrete structural element. In that we are going to do with various structural components like a beam. First coming to the beam. So beam you already defined, it is a horizontal structural member subjected to the transverse load. So now coming to the behavior of a beam. You know that when I am going to subject a beam to any load, it will undergo bending. Okay. So now for example, take this. Okay. If this is a beam, if I am going to subject this, if I am going to subject to the transverse load, that means all the load that will be acting in the perpendicular direction. That means if this is a horizontal structural member, okay, the load will be subjected in the transverse direction. That means the load will be acting in the perpendicular direction and that load will be carried through the longitudinal axis of a beam. Okay. And another thing you must know, or you already know in the basic design of RC structural element, the beam will be subjected to the bending, that is flexure. The beam will be subjected to the shear. Okay. Once if a beam is subjected to the transverse loading, the beam will undergo bending. Is it clear? Once the beam will undergo bending means, okay, the topmost, okay, that means it will be divided into two zones. Okay, it will be divided into two zones. You already know from the basic RC elements. Okay, the topmost zone, once if it is undergo bending, that will be in the compression. Okay, and the bottommost zone will be in the tension. Okay, so once if the beam is going to bend like this, okay, the topmost zone which will be under compression, that will be taken care by a concrete. That means whatever the compressive stress that will be developed once the beam is subjected to the transverse loading, that will be taken care by the concrete. Same likewise, the same beam, if it is subjected to the same transverse loading, in the bottommost zone, that is in the lower zone, below the neutral axis, it will be subjected to the tensile stresses. So that will be taken care by the steel. So like this, so these things you must know before you are going to assess the things. Without knowing these basic things, you cannot go and conclude or diagnose or come to the conclusion that so this is the so and so damage that has been happened. So likewise coming to the column. So you already know the column is a compression member. That means it will take more amount of compressive loads. And this particular column will can withstand the beam load, the slab load. And all these beam and slab load will be transferred to the floor. Okay, and coming to the column behavior, you already know that column is a compression member. And all the load will be transferred through the CG of a column. CG of a column. Whatever the load that will be transferred by beam and a slab through the column, okay, that load will be passed through the centroidal axis of a column. That is parallel to the column. Parallel to the column. That is parallel to the longitudinal axis of a column. Is it clear? Hence, the reinforcement also will be provided in such a way. Okay. Now, if the same thing, that means if the same column, if it is eccentric, eccentric means whatever the load that will be carried by a column, it will not passes through the CG of a section. That means there is a slight shift from the CG. That is called eccentricity. If there is any eccentricity, then the column behavior will change. Obviously, okay, once if it is buckle or something like that, the outward portion will be in the tension and the inner portion will be in the compression. Is it clear? And also you know that the column will be fail under various phenomena. It will undergo buckling failure, it will undergo crushing failure. For example, the long columns usually undergo buckling failure and a short column undergo crushing failure. Okay, so these basic things you must know before going to the assessment. Why? Because I have been discussed in this particular session, because all these things are elementary, one must know before going for the assessment of a concrete structure. Is it clear? Okay, now with these basics of reinforced concrete structure, I have been discussed beam, column, likewise slab also. You must know how exactly the slab will bend, okay, how it will be carry the load, how it will transfer the load, okay, likewise footing. Okay, so if you know the structural components of all these things or behavior of all these things, then only you can diagnose the things properly. Then only you can conclude this is the so damage that has been happened to the reinforced concrete. Okay, so with this, let me go with some further about the purpose of damage assessment. So next, once, or I can say, you can see from the objectives, once if I am going to evaluate or assess the building, if I am not going to observe or if the building will not show any signs of distress, any signs of damage, that means that building, okay, has passed or I can say possess all the things, that is, I can say it satisfies the safety, that means limit state of collapse. It will satisfy limit state of serviceability. Okay, as per IS codes, that means you know already been learnt in your basic reinforced concrete structural element class. Okay, you know that any structural component you are going to design or analyze, okay, it should pass the limit state of collapse and limit state of serviceability. Then only I can say it is fit for use. Okay, so likewise, okay, a building, if it not show any signs of distress, that means if any structural component does not show any signs of distress, that means it satisfies the serviceability criteria and also it will satisfy the safety criteria as per the IS codes. Then what I can declare, that building as, okay, that's what, no action of, that means no retrofitting, no restoration, nothing is been required for that particular building. Okay, and this situation you people will come across. For example, we have been structural consultant for various buildings. You will come across a circumstances in such a way that usually client will contact you people to do the assessment, that is stability assessment. So when you go for a stability assessment for a building, or they will say, sir, I want occupancy certificate or stability certificate for that building. So once if you go for the diagnosing that building, if you not observe any signs of what I can say cracks or damages, anything, that is one way of physically observing. And also we are going to do the modeling, remodeling, analyzing that components, whether they have provided the reinforcement properly or not, whether the provided reinforcement is matching with the design reinforcement or not. If everything is okay, then only I can certify this building is safe for occupancy. No need of retrofitting, nothing. So that is what the first case, that is A, I can declare. That is what the purpose of damage assessment. Coming to the second case. If a same building I am going to diagnose, I have been observed some deficiencies in the building. It may be in the cracks, maybe in terms of in some other reason. Okay, if that deficiency, okay, or distress, okay, whether, okay, you are going to observe that, you are going to observe that particular crack, you are going to observe that particular damage. Now, you need to judge, you need to come to the conclusion, or you need to diagnose that. Okay, after diagnosing, you need to come to the conclusion that whether that building can be repaired, whether that building can be retrofitted, whether the building can be restored. Okay, so all these things I need to assess, or I need to diagnose the things for that particular building. So that is what the case may have been written. Okay, why? And after suggesting those repair or retrofitting or whatever the things, that should satisfy the IS code requirements. That is the second case you will come across in the assessment of building or reinforced concrete element. First case, no damages, nothing. Okay, it is safe under all circumstances. Second case, you have been observed, a little bit damage you have been observed in various structural components. Whether it is safe or unsafe, you need to judge. Okay, and if it is unsafe, you need to do for something like retrofitting or restoration or some light repairs. You need to conclude, okay, based upon the IS codes, okay, we need to go with the techniques or assessment techniques. Okay. Last thing, coming to the next, that is the case C, okay, that is the building is badly damaged. The building is badly damaged, and next it is to be demolished and a new building may be built. Okay, that means you will, certain cases you will come across a situation in such a way that you will come to the third situation, that means that building, nowhere the structural component, okay, will be safe enough to carry the load. Nowhere the structural component is safe enough to carry the loads. That means it has been severely damaged. It may be called, wall may be, okay, tilted too much, okay, your slab is, the reinforced, the junk of a concrete has been spalled too much, the reinforcement has come out, okay, the beam has already showing a lot of deflections, the column has bent, okay, like this. If the severity of damage in the structural component is high, if severity of structural that is damage is high, then I need to, that means if I am not able to retrofit that component, then I need to certify that this building is not safe enough to carry the loads. This building is not safe for occupancy. This building is not able to carry the loads. Hence, I am going to declare that this building is not safe. So, this is the third case. So, why we discussed this purpose of damage assessment here? Because when you are going to inspect the building or reinforced concrete structure, it may be bridge also, it may be dam also. So once you are going to inspect that particular structures, you need to properly diagnose the things. Okay, because your decision is very important for a client. Because the client has put a lot of money on that building. If you are not able to properly diagnose and give a solution, then it may be lost to that particular client. Okay, and also you are not being diagnosed that particular problem. So that's why this purpose of damage assessment plays a very, very, very important role. Is it clear? So this is about the purpose of damage assessment. Hope the things has been clear. Okay, so these three things you will come across, okay, while assessing the damages in the reinforced concrete structure. So this is the conclusion part, or I can say the objectives what have been showcased here. So if I want to come to the conclusion like this, first of all, I need to know regarding the reinforced concrete structural elements. That is the prerequisites. I need to diagnose it properly. I need to do lot of things to come to the conclusion. Simply I cannot say it is unsafe for occupancy. Simply I cannot say safe for occupancy. Simply I cannot say go for retrofitting. So that's why the damage assessment plays a very, very, very important role. Very, very important role. We will see further what are all the things you are going to learn from this particular module number 2. Okay, so this is about purpose of damage assessment or objectives of damage assessment or necessity of damage assessment, I can say. So with this, I will continue further. Next is rapid structural safety assessment. So now, you will come across a situation in such a way that you need to assess the damage, or you need to say that particular, that is a damage, or you can say quantify the damage or assess the damage in the reinforced concrete structural element in a very fast manner, or I can say rapidly. You need to come to the conclusion very rapidly. Why? Because you will know that. You will know why we need to do the rapid assessment. Okay. This is not a usual structural assessment. That is, I am going to do the next thing. First, I am discussing rapid structural safety assessment. Okay. Let me go ahead. The rapid structural safety assessment should be performed in the following ways. Number 1. Review the entire outside of the structure. The first point. That means, once, okay, you are going to visit the building, the very first thing is, look at the periphery of the building. Look at the periphery of the building. Okay, why? Because you need to see the periphery of a building. What is the extent of a damage that has been happened? Why? Why I need to look up the outside of a structure thoroughly? Because clearly the second point says, see, enter the building only if necessary to determine the extent of damage. See, if from the outside itself, if you know that has been severely damaged, next the second point will fail. You need not, okay, no need to enter that particular building to diagnose the damage, because the building has severely damaged in such a way that you cannot enter inside the building to assess the building. That is what he is saying. Okay, that is what you need to do. Okay, the outside periphery of a building you need to observe thoroughly. Okay, and the second point, enter the building only if necessary to determine. That means, if you are not able to diagnose the damage properly, once you look at the periphery of a building, then enter the building if it is safe. If it is safe. If it is severely damaged, you cannot enter. For example, fire. Okay, for example, fire. So once the reinforced concrete element is subjected to severe fire and it has been damaged severely, okay, then you cannot enter. Okay, or if the building has been collapsed too much, okay, all the reinforced concrete structural element has been collapsed, then you cannot enter so easily. That's why the second point says that enter the building only if the necessary to determine the extent of damage. Next, once a building is safe to enter, okay, you have been entered the building, okay. Next, the third point say that determine what extent of damage found in the structural and non-structural element. So now, you have been observed the outside periphery of the building, you are not able to come to the conclusion, you get inside the building. Next, the third point say that, okay, determine the extent of damage, quantifying the damage. That means, okay, you have been learned the so many causes, shrinkage, okay, honeycombing, chemical attack, sulfate attack, corrosion, lot of things you have been learned. So now that particular concept plays a role here. That particular concept you have been learned plays the role here. What that role? Next, after entering, I need to quantify the extent of damage that has been happened. That means, for example, in the beam, what is, okay, the deflected that has been happened, how much of spalling that has been happened, whether they have given a proper cover or not, what is the extent of corrosion, okay, all these things you need to know. Likewise for column, likewise for slab, likewise for footing. So you need to assess, you need to note down, okay, the extent of damage. You need to note down the extent of damage. Okay, sometimes you can know, okay, physically by observing this. Okay, sometimes you need to take a photograph, come to the office, okay, diagnose it properly, why it has been happened. Okay, and also sometime you are going to take out the junk of a concrete. So all those things I am going to discuss. That is what the techniques I am going to use. Because you cannot immediately come to the conclusion it is unsafe or safe. That is what I have been highlighted in the purpose. It is a very, very important as a structural engineer, as a design engineer to come to the conclusion. I need to do the lot of assessment before coming to the conclusion. Is it clear? Okay, next. They have been bifurcated structural. That means structural elements like beams, slabs, footings, like that. Non-structural elements, that is partition walls, okay, the glassware, so many things, windows, all those things. Okay, and I need to bifurcate because I cannot say only I will go inspect the beam, slab, column. You cannot say that to the client. Once if you are going to enter the building, you need to observe every corner and each and every materials. It may be glass, it may be window, it may be door, whatever it may be. Okay, all the things you need to quantify it. Okay, extent of damage. And the next, secure all the areas that need to be isolated and post unsafe signage. This is very important. See, whether it may be after quantifying the extent of damage, okay, I think say 25 to 50% you have come to the conclusion that this beam is or this slab or this column is not safe. Okay, so immediately I need to post a signage or I need to say a client that this particular area is not safe. So please tell all the persons, okay, not to enter this particular area. Okay, anytime this particular area may collapse. Anytime this particular area may collapse. Hence, posted that particular sign, this is not safe, that is unsafe. So that you are restricting that particular area to enter. Okay. So this is the postage or signage you need to post over there or while doing the assessment technique. So these are all the things you need to do. So that's why the rapid assessment plays a very, very, very important role. Is it clear? So next. So that is what I have been told. That is objectives. The objective of rapid structural safety assessment is to inspect and evaluate and determine if the damaged structure is unsafe for person within the building. So that is what the object. Inspect and evaluate the damage, the extent of damage you determine, and immediately post the signage. Because you will come under the situation, okay, in a building in such a way that you cannot say that at what circumstances this beam or slab or this floor may collapse. Or if there is any severe problem, you need to immediately do the rapid assessment, okay, and immediately you need to post. You cannot wait for longer time. You cannot wait for longer time. Okay, immediately you need to come to the conclusion. Okay. Next, assessment include, that's what I've been told, structural and non-structural, that's what beam, column, slab. Next, non-structural or structural debris, partition wall, ceiling, glass, pipes, that's what I've been told. You need to bifurcate structural and non-structural and you need to say whether it is safe or unsafe. Okay. Next, that is what? If there is any visual signs of structural and non-structural damage, that means you can visualize the damage, then that specific building need to be isolated or area need to be isolated. For example, in that building, one particular floor, okay, you cannot enter. It is not safe. Or I can say in that one particular floor, some area is not safe. So you need to post that particular signage that it is unsafe. Okay. Next point, that is the rapid structural damage assessment would note major failure within the structure includes major structural element, beam, column, roof, that is slabs, everything. The unseen commander should be notified immediately of the risk and area. That's what. Okay, if immediately if the beam, if it is going to fail, okay, that depends upon the extent of damage, how much it has been deflected, okay, how much it has been lean. the column has been leaned, how much the slab has been deflected. All those things you need to analyze and you need to give the conclusion. Next, the rapid non-structural damage assessment would note major failure within the building. That means how you are going to diagnose the building for a structural part. Also, some damages that is going to happen for a non. For example, the glass. For example, what I can say, if there is a glass facades, okay, the glass facades, if the glass facades is completely broken, okay, if that glass facade is, okay, or I can say whatever that window you have been provided, okay, that means completely that has been broken, any chance it may collapse. Any chance it may collapse. Okay, at that circumstances, you need to provide that signage that you should not enter that particular area. So likewise, you need to do the rapid assessment, okay, to come to the conclusion. Okay. Next. Likewise, I have been showcased, a concrete is a brittle material. That means when I come to the concrete, you know it is a brittle material. It will not take much load. Okay, day by day it is going to crush. Not able to take, that is what I have been highlighted. It is a brittle material, a tendency to fragment into small. Okay, so you need to dense hard pieces with rough edges settlement or shifting of damage. That means when you want to, for example, this particular floor has been damaged. I need to shift this. I cannot do like that. I cannot do like that. Because it is a brittle material. Okay, a concrete, I cannot shift that particular floor. Or I cannot do such particular tasks. It is too dangerous. I cannot do also, okay. Next, depending upon the structural and non-structural elements within the building matrix and their relation to rescue or recovery activities, there may be varying importance of ability of these elements to provide adequate. For example, a failure of a column at a ground level may cause failure of a, that means, for example, if there is any failure of a column in the ground floor itself, okay, if your topmost floors are safe, it is of no use. It is of no use. Like how the human being, for example, if your leg is not strong enough to bear your upper portion, okay, then how it will bear? How the leg will bear your upper portion of the weight? If your leg is strong, it will bear the entire weight of your body. Likewise, if the ground floor column is strong, it will bear the entire portion of a building or entire building, I can say. Okay. Next. This is the other part. Okay, while doing the rapid assessment, you need to take certain equipments like flashlights. For example, if it is a room is dark, you cannot assess properly. You need to take a flashlight. Okay, if lighting is not available, then take a notebook, pen, pencil. Okay, that means you need to take a flashlight or a torch. You need to take a pen, you need to note down the things, you need to draw the sketch of that, okay, things. You need to take a pencil, a paint, spray paint, because you need to mark that particular area. This is so and so things. Column number, floors, okay, you can mark. So that's why you can take a paint. Okay, camera, so that camera is very important. You can take a photo and you can come to the office and you can diagnose it and you can come to the conclusion. Okay, and the next thing is very important nowadays. That is personal protective equipment, that is PPE things. Okay, PPE things means, for example, if we come across such a situation like tunnels, dams, infiltration galleries in a dam, you can see infiltration gallery assessment. When you're going to enter to that particular dark rooms or dark area, then, okay, the oxygen level will be decreased. Okay, then at that particular instance, you need to wear the PPE kits. You need to take the oxygen, whatever the things, okay, that is a respirator protection, okay, and you need to enter. You cannot enter simply to that tunnel area or to the infiltration gallery to inspect that particular structure. Okay, so these things you need to carry, that is flashlight or torch, pen, pencil, notebook, okay, camera, okay, PPE kits, these things you need to take, okay. So like this, you need to go with a rapid assessments of these things. So why I have been highlighted here? Because you will come across a situation in such a way that you need to give an immediate conclusion for that particular building. Because if the collapse is more, okay, then you need to immediately diagnose and you need to immediately state the condition, because anybody within that particular area are going to occupy, or if there is any person working under that, is too dangerous. So that's why as a structural engineer, as a structural consultant, you need to immediately come to that conclusion and you need to assess and you need to give a conclusion to the client that it is not safe to enter this particular area, this particular floor. Like that you need to, conclude. So like that we need to go for a rapid structural safety assessment. So this is the one thing have been discussed. Regular assessment, how you are going to do, that I am going to discuss in the next sessions. So in this particular session we have been learned what is the necessity of damage assessment, or what is the purpose of damage assessment, and the next thing is how to do the rapid structural safety assessment. Okay, so hope the concepts has been clear. Okay, with this discussion I am going to end the session of today. Thank you.